is about using Python and using flowcharts and using pseudocode at school. So it's very different from the other one. I want to say something about me. I'm a teacher. I like to program. I'm a teacher in a high school in Verona, and I teach computer science also in the primary school with Scratch. I teach in the middle school with Lego Mindstorms, and I am adjunct professor at the University of Verona. So I have a quite big horizon about teaching from primary school to university. I'm very interested in education, in problem solving, in computer programming, teaching, and education. I have a cousin. His name is Massimiliano Masetti. He's also a teacher. He made a web application called Leap. The goal, the purpose, the aim of this application is to teach computer programming. It's a pseudocode program. So I wanna talk about this testing in the high school we made. The main topic of this talk is educational programming. The subtopic is how to teach to be smart, how to teach to use intelligence, not to be intelligent, but to use intelligence. So I want to start from the etymology of this word. We have mainly two meanings or two etymologies. The first one is intus legere from the Latin. So we wanna go inside things. We don't want to be superficial. We want to be deep. And the other one is interlegere. So is to collect something, to join things. This intelligence. So we want to teach, to learn to be intelligent. We want to teach to be intelligent, to use intelligence. So the goals, the reference context. We want to find tools and pathways to give an introduction to coding, mainly in the secondary school. But the aim is also for primary schools and for middle school. The ratio of my talk is educational, so it's not so high like the other one of Alex. We have two general axioms. We start from coding like a difficult task. It's not so easy to learn how to program, and I think it's very hard to teach how to program. It's very difficult in this age, in this period, and this time. And we still, I think, don't have the best language for everyone. Saying this at the PyCon, maybe it's an heresy, but I love Python, but I think that not everybody is good for Python, or Python is good for everybody. For me, it's the perfect language, but not for all situations, and not for everyone, not for everything, and not for everyone. So there are historically three main methods or main ways to teach how to begin to code. We can begin from flowchart. Some pupils visually learn. So they like to have a visual representation, a graphical representation of the solution to the problem, the algorithm. Someone prefer to read and write textually. So they prefer a pseudocode, so something between the natural language and the machine language. And then we have the programming language. We have all these three methods used in the school, in the secondary school. We have teachers that drop away flowchart and pseudocode. They go directly to programming language like Python, for example, or Java too. I think that Java is not the right one to begin. Maybe the second one, but not the first one. So I prefer to use Python to introduce, and maybe after we can go to OOP, object-oriented programming, with Java. Then flowchart, some features, is old and stable, is schematic, is intuitive, because it's graphical, it's visual. It's well supported, it's quite simple, but it's not really standard. And I think that is useful, is really useful, only if we remains with at least about 10 blocks, no more. Because more than 10 blocks is, I think, a contradiction. Because we want to simplify, and we have a more complicated representation, a more complex and complicated representation. So the purpose of this tool, of flowchart, is not used well in this case. So it's very nice for me, it's useful, but only with 10 blocks. It's not really standard. For example, I use only 7 blocks, types of block, arrows included. But not all are very standard. For example, the input-output block are a little different from one to another. And sooner or later, we need to get to the text. Why? Because the power of the text is unreachable for now. So, flowchart, we have, for example, Java block is a useful tool, a useful program that we can use to, for example, to watch how is the execution, and it's very easy to understand and to see the value of my variables during the execution of code. Here, for example, I have a simple input-output and a loop, a very simple loop. It's very easy to understand the flow chart and the flow of this program. Here I'm talking about a program, but it's not a program, it's an algorithm. So we have here an oxymoron. We have a contradiction in terms, but I will talk about this later. We have another one, is Argo build. Some teachers use this tool, and it's easy to use it. We have an output window, variables here too, and we have also we have a pseudocode. So we have both in the same program. Pseudocode features. So from flowchart to the second one, from the first one flowchart to the second one, pseudocode is clear. As simple, already textual. Intrinsic limits for me is that we don't have a standard. We have some Pascal-like pseudocode, C-like pseudocode, Python-like pseudocode. And normally it's not executable because we are in a pseudo language, not in an executable language normally. Then a programming language, we have two types mainly, graphical languages and textual languages. But graphical user interface based language are too easy. Too easy means that the pupils can't go deeply into the topic. So they can't understand, really. It's easy to create a form, to put controls inside the form, but they don't understand the algorithm. They don't understand the logic. Then we have CLI, so textual language, but they are a little too complex for many pupils. So LEAP is this the manifesto of LEAP. We want to offer an alternative to Flowchart and try as soon as possible the algorithm. Try, prove. We want to start coding with a minimum number of technical concepts. So this is the website for LEAP is free to use and is open source. It's made with JavaScript. So it's a web application for pseudocode execution. Verification of result, we have a track table, step-by-step execution. So we have a pseudocode with no magic, like in Python, something like this, or no many magics. We have some oxymorons, because it is a pseudo language, not a language, but is also a language. Is a tool to describe algorithm, not to write programs. So description versus execution is a semi-formalism versus a formalism. But I don't do computer theory. I do computer education. So it's not really important for me. We have a syntax, but I want to show you something here with the browser. I want to go here, and for example, I can here execute the code line by line. Here I have the input. I can read something. For now, is it only in Italian. Here I have the trace of my execution. I have the values for my variable, and I can save here my code. So, for example, this is another program. It's really simple. Some pupils like this. So, I want to, sorry, I have to find my presentation. I've lost LibreOffice presentation. Where is it? Okay, I'm sorry. So, educational testing in high school, in liceo, and then for computer science experts. So the results: Python. Okay, thank you. Python and pseudocode and LEAP together, for me, are easy to learn. Easy of learning. We have a simple interface. We can offer a choice for instruments. So, for example, in a test, I say you can choose if you want to solve this simple problem with a flowchart, with a leap, so pseudocode, or directly with Python. And I see that someone chooses the first, the second, and the third too. So paper Cinza, this is a translation. We have something that normally we write on the class board that now can get into the laboratory. We have evident results too. I have no sufficient statistics yet to say how many students choose a flowchart or a leap or Python directly. But normally I think 10% or 15% prefer flowcharts, and the other one an half Python and a half leap, this pseudocode. So extra Python limits. There are too many unbelievers. I mean, in the world of teachers in high school. They want to teach only Pascal like they did 20 years ago or 13 years ago, or a COBOL too. There are too few evangelists or disciples of Python. And coding is equal to thinking. Thinking is a hard work. And I have to teach to digital native generation. So here we have the consumer and producer problem, because they are only consumer of code, not producer. Intra-Python limits, for example, version is a limit. For students, they don't understand, have I to install version 2 or 3, but if I use this, I have the print without parentheses. So, idle is useful, very simple, but sometimes too simple or too not so easy. For example, I use a Visual Python too, but for Visual Python, we have many problems with idle. So I have to use another editor, another IDE, like Vidle, Visual Idle. Indentation is good, but it's also something that is not so easy. And this is not really easy for students to understand that they have to convert this to string. In Java is simpler. We don't have to convert to string a number. Here we have to do this. Okay, for leap we have many things that we can do. We have a bridge from theory and practice, a bridge more from theory to practice. We can try as soon as possible primary concepts of problem solving with Python and leap. And most of pupils won't hate, maybe, coding with Python, like they do many times with Java. Leap and Python are semantic frames, so useful like other tools like laboratory or pen and paper or Scratch, and allow to make a bridge in a more mind. Thank you.
Hey, loved it. Thanks. My first question is, you mentioned that some students choose to use flowcharts, and there are some others that prefer pseudocode, and others that prefer coding on real languages. But you also mentioned that you think and you believe that students have to go from flowcharts to actual coding at some point. So how is that process? How do you encourage students that choose to use flowcharts to go to actual code and running their programs?
Okay. Because they have to do this. Because when the problem is simple, they can choose. But when the problem is a little complex, not so complex, they understand that they can do this with a flowchart, because they see something that is understandable. So it's almost natural with the path of my lessons, with the problems.
So yeah, the second one is, have you used Scratch?
Yeah.
Okay, what do you think about it?
Oh, I think it's perfect, but I use it for example, I use it in primary school, in many classes. For example, in 3 days I have a Scratch day. I organize a Scratch day, and I will have, I think, I'm going to have 50 pupils. In high school, I use it only for 4 lessons. Then I do a test in Scratch, a video game in Scratch, like Super Mario, something like this. Then I have to pass to something textual. You're welcome.
So how is your rate of retention of people who go through your basic course, taking a second course in programming?
So, do you want to know how is the path from...
Do more people choose to continue on with programming now that you're doing it this way versus older ways?
Yeah. I really don't know this. I really don't know. The only thing that I can see that is the last one, that not many of them hate coding. Don't hate coding. Yes, I think so. And the problem is maybe more in the gender, for girls. So they like, for example, I have here. This is a picture of a solution of a test. They have to find how many vowels are in a poetry, in a composition. And here, for example, A is 11%. And here, they made also a visual representation with Visual Python. So they like maybe more coding, programming.
Thank you, Maurizio. Again.
Thank you.
And we are going to start again with Flavio's talk in a few minutes.